So as Julie mentioned, my name is Michael, and I work at a company called Energi, and we are trying to build the world's first virtual power station. And we'll explain what that means in a minute. First, let me say that we are very, very early in our journey towards very good data governance. And I come here not as an expert on data governance. There's plenty of people in the front row who are experts. I come to you as someone who is a data architect that has legs in pretty much every spoke of that clock wheel that we saw. And so I want to talk to you about the challenges that we've had so far in managing data quality and data security. So what exactly are we trying to do? I've used this lofty word with virtual power station, and I feel like I should spend a few minutes and actually explain it. So when Thomas Edison built the first power station, it was only used to about 18–19% capacity. And you might think over time we've gotten much better at doing that because there's some technology and we're pretty smart people. But in fact, it's only gone up to about 25%. And why do you think that is? Is that because we're not good at doing our jobs? Is that because they break down all the time? Well, no, that's not why it is. It's because the supply on the network has always been thought to be something that we can't reason with. It's something that we can forecast. It's something that we can build extra capacity for, but it's not something that we can tamper with. You can't call somebody up and tell them not to turn their kettle on. It doesn't work that way. And what we do is turn that around. We connect lots of industrial assets, such as chillers, fridges, foundries, bitumen tanks, and we use their data to determine when we can defer their power consumption or when we can bring it forward. And that we synchronize with data we get. It's available in a plug socket that measures instantaneously the supply and demand on the grid. So on a second-by-second basis, we're able to adjust our virtual power station made up of all these assets to help balance the grid. And why do we want to do that? Why isn't it just better to go and build more power stations? Well, cost. We don't have to build anything. We just tap into assets that are already there. And what we do is about 20 times cheaper than what power stations do. So what is all this data that we want to govern? Where do we get it from? So our solution looks like this. We have assets on site, so they could be fans, they could be bitumen tanks, anything. We pipe all this over 3 or 4 key connections back to, let's say, a central logical location where the data is collected, it's refined, it's validated, and a bunch of processes happen that put it in a form that we then report to our customer, the national grid. And you may have heard of this Internet of Things phrase. Maybe you know what it means, maybe you don't. If you have a precise definition for it, then please let me know. But what people mean the Internet of Things by the Internet of Things is usually things, devices, that are connected to the Internet. That's why it's called the Internet of Things. And our solution fits into that because we connect to lots of very small and very big devices all over the UK, and then hopefully one day maybe all over the world, who knows. And we learn about their behavior, we control their behavior, we orchestrate their behavior to achieve one common goal. And just to give you an idea of the potential scale of this data, there's been an enormous explosion of the number of connected devices. Back in the 80s, or well, I'll say back in the 90s, because that's more my generation. If you had a computer with internet, you were doing pretty well. And if you had a computer with internet that didn't make that modem sound for about half a minute when it turned on, yes, that one, then, well, I don't think that was possible. We didn't have that then. But if you had a computer with internet and it worked, you were doing well. And now everyone's got a phone, they've got a smartwatch, they've got a computer, they've got a smart fridge, they've got a smart car, maybe they've got smart shoes. And this stuff isn't going away, it's just going to get bigger and bigger. And as you can tell from the graph, Cisco thinks we're going to have 50 billion connected devices. By 2020, we want to tap into as many of them as possible because some of them have inherent storage. For instance, the fridge in your house, you can leave the door open for 10 or 20 seconds while you're putting food in, so food doesn't spoil. You could turn it off for a little bit. You could turn it on earlier, and that could help balance the grid in some way. And that's the kind of thing we want to do. And so what kind of data are we talking about? Well, we're talking about ingesting about 30,000 messages per second at the moment from all these devices. These are power readings, these are temperature readings, these are possibly alerts that we get from these systems. These are all data that somehow fit into this system that we then have to make sense of in order to report to the national grid. And so what are the governance considerations? So when I say governance here, I'm speaking mainly of data quality, because that's mostly what I deal with, data quality and data security. I think to talk about the whole wheel of data governance might take a bit longer than just 20 minutes. And there's some things that are very unique to the Internet of Things, the precision of timestamps. If you look at a message that's generated by your computer, say, and you only care about the time that's on your computer, then you don't really have to worry about whether your computer's clock is synchronized with any other clock, really. But if you're dealing with 2,000 devices, some of them might have intermittent connections, some of them you might not even control the software or the hardware on it. How can you trust that a device that tells you it's recorded a certain reading at a certain time actually did that? How can you trust that? It's actually a huge problem. It's not a huge problem in computer systems because there's protocols that let you synchronize them. But in really constrained systems where you might not have outbound connection for maybe 8 or 10 hours at a time, it is a real problem. Provenance of power consumption data. We have some really strict requirements on what kind of meters we're allowed to use. And even then, there's some interfaces to these meters that have parameters, like how often we hold them, and when to trigger a new reading, essentially. Do you want to know every time that your fridge consumes an extra 0.1% of power than what it was previously doing? Probably not. But there is a setting there, and we have to be careful to respect those, otherwise the accuracy of our data goes down. Data can be revealing of industrial process constraints. The amount of things that we can infer from our customers' data is really staggering. So we have to be very careful to protect that. Mandatory retention periods and APIs. The thing about the IoT is that it's all about open source. It's all about sharing data. It's all about sharing interfaces so that people can connect to things in new ways. And this means open APIs. This means people being able to send us data without us ever being on site and actually being able to verify the installation. How do we make sure that they adhere to the same standards we do? And how do we make sure that data owners within those organizations validate that data in the same way that we do? And I want to give you an example, which is a real-life example from, well, I'm not going to tell you where it's from. I'll tell you later where it's from, so you can maybe try and guess. This is a pretty harmless, well, it looks like a pretty harmless statement. An asset reports a power reading of 100 kilowatts at this time. For those of you who are inclined to see what the exact message looked like, it looked like that. That's pretty harmless, right? Think a power reading, that's pretty well defined. 100 kilowatts, well, in fact, it's sent a value of 100. We think it was kilowatts, and that's the time it reported recording that reading at. That's a pretty harmless statement, right? Well, not really. In fact, a toilet fan was consuming as much power as 100 kettles. And we caught this because we had some anomaly tracking software that suddenly recorded a little blip, and we then decided that data was probably not valid because there was no curry night going on at the supermarket where it reported. So let me go back to this for a minute. And this is the problem with open APIs. You have to be sure that partners who are sending you data do so according to your own definitions. But we realized that when we said power consumption, we were very silly. We forgot to specify the units. So they were sending it in watts. So in fact, there were a few extra zeros there. The timestamp, well, in that case, there was probably nothing wrong with it, but we need to have a very particular specification there that says you have to synchronize this time server, and you cannot let your clock drift by more than 100 milliseconds, otherwise that affects the accuracy when we aggregate it. For instance, as part of this open API, partners are allowed to send any kind of data they want if it's meaningful to them. But can we really ensure that if they send a type that's called stage 2 power of something, is that meaningful to them? Do they control that definition, or are they going to send something else in a week that they can't make sense of, that they're going to ask us for? And we have to make sure that they understand as well as we do that we want to be open, but at the same time, we have to ensure the quality of the data going through our system. And historically, we've done this in two different ways. Now, the way we make money is to prove that we've delivered the service. And the way we prove that is by aggregating power data across thousands of assets and saying, look, we decreased the power consumption of these assets by so much at this time, and we helped balance the grid. That's how we make our money. And our initial approach to this was just to reject data that we thought was incorrect. There's a slight issue with that, which is that every rejected data means lost revenue. So is it possible to repair that data? Is it possible to do it after the fact? Well, we can't do it after the fact, because if we did, then every time there was a blip like that, then there's a screen in the National Grid Control Room with our service levels on it. Well, it might have a bit of an anomaly on it. That wouldn't be great. So we've come up with another solution after experimenting with this, which is well, partial validation or soft validation maybe, which is where we send data to a second place if we think that it's suspicious. And then there's either automatic processes, most of them are manual, or we'll then have a look and try to figure out what went on and contact the relevant people. And this is where it's important to have data owners within our partners that we can contact and say, look, we agreed to this definition of data, and what you provided maybe doesn't quite fit with that. So, you know, could we figure out what's going on here? But in the spirit of the IoT, you can't have absolute rules either. One example was that at one point we had a hard-coded rule that no asset could ever consume more than 1.5 megawatts of power. We never thought we'd be connecting to anything that big. And well, obviously what happened, we ended up connecting to something that big. And we ended up losing a little bit of data as a result, actually, not a lot. But it shows that absolute rules like this just shouldn't exist. You should always have something which is configurable. And in fact, because we're a small company, we think that you should even have rules that even non-technical people can see that you need the tooling for non-technical people to be able to inspect these rules and inspect these processes and audit them at any time to see the lineage of data going through the system. And there is tooling nowadays that lets you do that. It's just a matter of getting the right people to use those tools and really telling them this is your role within the governance process. And then, of course, there's adaptive rules to detect anomalies if the other rules don't work. And that's something that we've got quite good at. I know this is not anything about tooling. This is, I think Julian made it very clear we're not going to share such details, but I thought I'd just show what we use. It's an open source tool called NiFi. It's free. It's nothing to do with us. And it can show you things like data lineage, data provenance. You can see exactly where data is getting validated or invalidated, as the case may be. And because it's visually, the non-technical people can use this. And we had some success with even senior people who really hate looking at technical things to just go into this and say, look, why did I lose this much power last week because we considered data invalid? Why did we think that data didn't meet our standard? And they can go and they can find the answer. And so the second thing I wanted to talk about was to give you an example how difficult it is to secure human access to data in the IoT. And IoT data is usually associated with the phrase big data because it has to come from lots of devices, there has to be a lot of it, flows very fast, and generally it's very big. And the thing about big data systems is that they were designed by researchers, for use by researchers, and only recently have they been brought into the enterprise. So what challenges do you face? Well, you have a big data platform versus your traditional enterprise BI system, which maybe can't cope with that volume of data, but at least you can control who has access in a much stricter way. A permissive API or a restrictive API, do you just reject everything that doesn't meet your standards, or do you put it somewhere else and try and work with people to resolve it? Because it's fundamentally, it's a human issue. It's not really a technical issue. Well, it is a bit, but it is a human issue originally. Cloud computing on-premise, maybe there's regulatory issues that you have to have some types of data on-premise versus on the cloud. And then the last one, which is, I think, as a data architect, is my personal favorite, is when people want to have data, the same piece of data all over the place because this type of database works for them or this type of database works better for a team. And all these different databases somehow need to have the same security policy. How do you do that? I mean, from an IT point of view, it's a complete nightmare. And I wanted to take that earlier example again of the asset reporting, a now corrected power rating to 0.1 kilowatts, and show you that, that no matter how you cut it, you have one security policy, but you're always going to have 2 or 3 different implementations of that policy across different systems. For instance, you might have some primary database that's your source of the truth, and that has one implementation of the security policy, which probably can share that with some sort of replica. But then your API, which you've implemented, is a completely different system, which maybe it can share that colored differently. In our case, it doesn't. Maybe you need a different implementation, and you need to then test and make sure those implementations are the same. In the early days of Open Energy, we didn't really have that testing. However, we had different logins for all these systems, and the access groups were slightly different for all these systems, and the people then in charge of defining the security policies had to create slightly different policies for all these systems. I'm not going through the rest, but you can see that basically it can be a bit of a nightmare if you adopt this flexible approach to keep track of everything. And what we've found is that having one broad security policy that tries not to get too detailed, but that vaguely says this type of data shall be accessed by, broadly speaking, this type of person or this type of application, and then using some sort of using again some sort of tooling like API gateways or Ranger, which are again these are visual tools, allows us to get really non-technical IT folks to make sure that we've done our homework. And again, the point I want to stress is that we're a small company. We don't have a person who's completely dedicated to writing data governance or security policy. We don't have a person who's dedicated to implementing this. These are all roles within the business who have to work together and who have, well, sometimes conflicts of interest, even I'd say, in the sense that they're marking their own homework. You're looking at probably the person who has the biggest conflict of interest. But it's important to let anybody, I think, to let any senior stakeholder just inspect what we do. And I think a tool like this, where they can just go in and they can say, yes, data analysts should have access to this. However, a member of the commercial team should not, or this person who's an external user should be able to send us power readings because we've made sure that they comply with our requirements. However, they shouldn't have access to this system. And doing that from a central location is really hard, and that's where tooling can help. This is very early days. We're still, maybe 6 months, I'm really trying to define what data governance means for us in a small company, where we don't want to introduce too many additional processes, but we still want to have a good level of control over how our data is governed in order to maintain the highest possible standard of quality for it. I think that's all for me. Is there time for questions? Okay, I'll take any questions.
I'll add a question. So in terms of you saying you're a small company, there are a lot of people, a lot of organisations providing you with data. So your data governance challenge, your data specification challenge, actually could influence many, many organisations who each have their own approaches to data governance. How receptive are the people supplying the data to be able to talk intelligently about data to you?
That's a loaded question. I do know that we're watching right now. Well, I think what the first speaker was saying is spot on. We've got an IT team that implement the solution. We have an operations team that are in charge of validating the data on site and making sure that people understand what our quality standard is and how to meet that. And oftentimes getting the two to talk to each other is a bit of a challenge. That's where our team comes in, actually. It's sort of bridging the gap between the two and making sure that their definitions match. For instance, when I was talking about hard-coded, about never having a power over a megawatt or something, that was a rule created by the IT team, thinking that would never happen, and they never told the operations team about it. And we found out about it, thankfully. But it's a huge challenge to identify data layers for different kinds of data becomes a challenge as well, because instinctively we want to say, well, our team, as a data solutions team, maybe should own all this operational data because we know what it means, we know how it's collected, where it's stored, but we don't consume it. So maybe should the data consumer own the data? Should we just give it to our CFO and he can figure out what to do with it, but he doesn't know what it means. So it's been a huge challenge. think we're a lot closer now to getting people to at least talk to each other and to get the same definitions of data quality across the business.
You're obviously a young company, fairly startup type mode. You're obviously a data company as well. So you had the luxury and the challenge of starting with a blank sheet of paper. When you were starting out on this, was it sort of get something up and running and we'll come back and sort out the governance later? Or did you say, well, we're a data company, we need to make sure we know what we're doing, we need to understand the data that we're going to be managing in the future, but let's get it right and then think of flipping it. Well, how did you balance that?
So when we first started, there was a real challenge in actually getting the national grid to believe that we could deliver the service. So part of that, well, actually, the biggest part of that was proving that our data was accurate and proving that it was measured to certain standards and that we could provide the service. So there were some governance, we didn't call it that, but there were some governance concerns in there to begin with. But now that we've sort of outgrown that initial approach and we're looking at accepting lots of different kinds of data and providing different energy services to different people as an IoT company. This is where we really need to start thinking about all those processes that, like you said, we hadn't really thought to begin with. We just thought around the process for our main activity, and that's it, and everything else sort of, I would say flowered around it, but it's probably a lot less real than that.
We've got time for one more question.
Okay, one more. Yes.
I suppose it's more comment really. Part of what we covered earlier about MIFID, there's a whole section in there about clock synchronisation and timing, and how important that is as well from there around trading, algorithmic trading. So yeah, that part of data governance is important there as well.
Has it been finalised yet?
No.
We'll take a look. Thank you very much.